KiD, KaVo Integrated Desktop. The Arcostigma KiD software is a digital data bank. Here you can store all digital information regarding a patient and pass this on to a third party. I have started the KaVo Integrated Desktop, and via this screen I can download and automatically install the latest updates. Here we can also adjust program options to suit individual requirements. Using the menu Patient, we can either select an existing patient or enter a new one. There are two compulsory fields for entering information. Firstly, the family name. Secondly, the given name. Optional fields include date of birth and a file number. Also, the sex of the patient is entered, here female. The entered data must then be stored in the data bank. This patient has now become automatically an active patient, and we can initiate the other menu points of our Arcostigma software. I can select a patient already stored in the data bank by using the menu Patient. All previously stored patients are displayed, and here I can select the desired patient as an active patient. All available records for this patient will then be displayed, and I can instantly carry out a further measurement using the menu Arcostigma. The connection to Arcostigma is made by selecting the sub-menu Start Measurement. The main menu then appears on the display. Selection fields with a grey background show that the appropriate sensors are not connected. In the main menu, all active software modules are now available to us. In the upper row, we have the modules for therapy, while the lower row covers the diagnostic areas. In the therapy area, here under Articulator, we can implement the movement recordings for determining the adjustment settings for the articulator. Next to it, we have 4 different software modules for the implementation of an indication-oriented centric purpose. In the lower row, we see the modules for position and movement analysis. A further module, the EAEF module, combines both areas for a special operation for the establishment of functional splint construction in function therapy. In the menu Patient, I can select a stored patient in order to analyze the recorded data. Here all previously recorded measurements are listed, from which I select the articulator programming by an initial click, followed by a double click to start. At first, one sees in the Start screen a 3-dimensional view of the skull. All the recorded measures of movement are registered as active, from which I can activate or deactivate on the display as required. Here I am now deactivating all measurements except the first one. I start the playback of this measurement and can see the movements made by the patient during the recording as a 3-dimensional representation. I can display this movement in various perspectives. In that I can change the various planes or angular views by turning the skull. I can also directly select default positions, such as the left lateral, the right lateral, frontal or horizontal view. Now I am changing to the area of trace display. Here I also have the possibility of switching to the various planes, or by turning to display a spatial representation. By clicking on various views of the left, right or both joints in the horizontal plane, I can freely select which I want to alter. In the lower row, views of the movement of the incisal point are displayed. Using the button Zoom and Shift, I can relocate, enlarge or reduce the display by selection. This means by clicking on a display window. This I can adjust individually for the various windows. For the middle window, which displays both condyles simultaneously, I go again into the horizontal display. However, here I have to adjust the enlargement in order to see both condyles. In addition, I can have further movement patterns overlapping. In this case, the active dynamic displayed movement is displayed as a coloured curve, while the other active movements are overlapped in grey. I now select a laterotrusion movement. As I would like to analyse this movement more closely, I stop the movement sequence. By clicking on the regulator, I can carry out a time option. This means selecting any desired position in the curve and analysing the various interesting areas. For this selected instance of the movement sequence, I can then add a comment. In the display of this curve, the movement sequence particularly attracted my attention, and I would now like to examine this more closely. Therefore, I am stopping the movement so that I can go through the sequence manually. Here I can see that during the retral movement a clicking occurred at this point in time. I can add an appropriate remark in the comment area and assign it to this point in time by Set. An appropriate marker for this note is to be found here in the time band. This means that when passing through this movement point, the comment will be automatically displayed again, correlated to the time I stored the information. At the marked point of the movement sequence, I can also make a root or angle measurement. At first I apply a reference line. And then measure the distance to my marked point. This is displayed as 1.7 millimeters at an an angle of about 39 degrees to the reference plane. In this way I obtain information for the specific setting of an articulator. If, for example, I wish to produce a protrusion splint in this position, I would like to know now if the movement disturbance visible here has occurred also by the other movements, and if I can superimpose a second movement there too. We have now displayed the first and the second left lateral movements over each other. The first is displayed in green as an active movement, and the second as a grey path. And we can recognize the same disturbance in both movement sequences. In order to produce the printout for the file or the laboratory, I select the appropriate record, go to Print, and receive the diagram of the curves with my comments printed out. Here I see the program values for the right joint, the left joint, and for the individual anterior guidance plate. Additionally, I get information for the dental technician from the display of the condylar paths in the sagittal and horizontal views, and separate portrayals of the retrusion path and the shift angle. Here I see the same for the left joint. In the centre of the printout, displays of the incisal guidance, the canine guidance, and the Gothic arch can be seen. Installation of the model should take place in position 1. This position has been calculated automatically by the Digma program in order to find the best possible setting for the articulator joint. I can obtain additional information from the graphic displays by clicking with the left mouse key on the desired display. I can now measure here paths and angles. First I lay down a reference line, and here I can survey the first part of the movement path. It is indicated concisely with 38 degrees. Measured over the total path, the angle changes to 37.5 degrees. Here I can also select the desired movement zone. Now we select the movement analysis, and in the middle of the screen we see a three-dimensional display of the cranium. On the left side, the plotted movement patterns are listed with an area for comments. All movement patterns are switched on. We can switch them off and on again selectively. The red arrow always indicates an active movement, which we can start and stop on the time band below. Here the movement sequence is displayed once again in real time. We can have this movement displayed in various perspectives by clicking on the display and adjusting to the various perspectives by dragging the mouse. Fixed settings in the left lateral, frontal and horizontal views can be directly selected. Clicking onto another movement pattern will automatically switch to that sequence. Here I am selecting a right lateral view in order to show the protrusion movement. The same can also be done for other movement patterns. Here a display of Posselt's diagram. In this band we can also switch to the various projections. Now we have a right lateral view. Using this switch, I can change to a left lateral view, or a frontal or horizontal view. I am switching back to the frontal view and changing the movement pattern from the sagittal to the frontal recording of Posselt's diagram. From the three-dimensional display, we can switch to a display of the movement sequence traces. We see a green trace for the right joint and red for the left. In the centre, a view of both joints in the horizontal plane can be found. The positions at the same point in time are connected by lines, so that from the distance between the lines we can also receive information about the speed at which the condyles moved. In the lower region we find three displays of the incisal point movements in the sagittal plane, as well as in the frontal and horizontal planes. In the time band, we can stop the movement sequence at any time and operate various points of the sequence manually. At this position, we can superimpose further movement patterns for comparison. For example, the protrusion movement, which is now additionally displayed in grey. By switching the actively displayed traces from open to protrusion, we can clearly differentiate and analyse the various movement patterns. After I have carried out an analysis of the whole movement, of course I would also like to create some documentation. For this purpose, all movement patterns are switched on. I exit the display and select Print. A report is produced, providing me with all selected movement patterns. Here the pertinent values for the left and right joint, retrusion and laterotrusion, etc. are displayed. On the second side, we see an analysis of the various movement patterns with my comments made during the recording of the movements. Here we find the movement display of the left and right condyles, as well as for the incisal area displayed in blue. For opening and closing, Posselt's diagram, sagittal and frontal, and the corresponding values for maximum mouth opening, here 41 mm. The maximum movement space of articulation for the left and right joints is specified here as 13 to 14 mm respectively. In order to carry out a comparison of movement analyses, which I have recorded at differing times, I can additionally select and click on a second movement recording and have this displayed in the report. Thus I have a comparison of the first and second measurements. I can well use this function to compare the movement patterns and areas before the start and after completion of the therapy. For evaluating the positional analysis, the corresponding record is selected and the measured points are displayed. The respectively selected position is highlighted yellow, so that I can compare between the various positions. Here I have now selected the position for a left lateral position. In order to be able to make the comparison more exact, I can also alter the zoom. That means the distance between two rings changes. close the display again in order to produce a corresponding report by using the function print. So I can add a printed version to my documentation. By selecting the appropriate drawing, I can also print out the centric position, which I have registered, in order to incorporate this also in the documentation. Hereby the end position, which I captured with my registration and previously determined as the desired centric position as a green circle, is displayed in the form of red crosses. To make the gained data available to a laboratory or another operator, I can extort this under an export function. For this I choose the pertinent records, go to the export function, and using the Explorer I can select the desired file in which I wish to store the data. I can then send this stored data by use of a data carrier or by email to the corresponding recipient. There, this data can be incorporated into the data bank system by using the import function. I start the import function with this switch, select the appropriate record in my data directory, and can now include this in the KiD data bank.